Okay, let's consider some specific algorithmic techniques. Okay, one of the data sets I want to use to illustrate these techniques is the passenger list from the Titanic. And this is a data set that's available out there on the web and has been used for various purposes, but it's also available as a Kaggle competition, and it's one of the competitions you can participate in. It's used for getting started, for kind of a training exercise. Okay, so what this is a one record for each passenger on the Titanic, or in the training set, a subset, along with various attributes that describe that passenger and whether or not they survived the sinking of the ship. Okay, and so the columns here are survived, which are given as 0 or 1, 0 meaning they did not survive. And P class is the ship's class, like first class, second class, third class, which sort of deck they were on. Gender, age, SIB, SIB-SP is the number of siblings they had on the ship. PARCH is number of parents and children. So number of children if you're a parent, or if you're, well, actually either way. So total number of parents and children. Fare is the fare in dollars that they paid. Cabin is an indication of their cabin number, and you can see that there's a lot of missing values here where either wasn't known. And then embarked is a one-letter code indicating where they got on the ship. Okay. So fine. So the first thing to do probably whenever you're tackling these problems is to inspect the data, right? So if it's sort of telling you something, you shouldn't ignore it. And if, more importantly, if it's not telling you anything, that's maybe a sign that it's going to be tricky to sort of learn a pattern automatically. And so one thing to do is to start plotting scatter plots of these various columns. And so one idea you might have is, well, maybe women and children first, right? Maybe the kids tended to survive, so you can plot age. And then maybe you might imagine that people who had paid more for their fare sort of had more influence on the ship. And so this is a scatter plot of age versus fare, and you can see there's probably not too much of an obvious pattern. There does seem, oh, blue here, by the way, is survived, and red is did not survive. So you can see that there's kind of a cluster of blue around, you know, the very young children maybe tend to survive much, but other than that, there's not anything really obvious here. Okay. Or at least it doesn't seem obvious to me. All right, another one you can do is age versus sex. And I played a little bit of a trick here where I'm plotting categorical data as a numeric attribute, which is a pretty useful trick to do. And you can see that this is also kind of smeared a little bit here. And what I did was add a little bit of a jitter so that you could see the values. Otherwise, you know, it's not that someone is sort of, you know, 0.1 male and 0.9 female or anything. It's just that if you don't add that jitter, then all the values end up directly on top of each other, and all you see is the last one plotted. And so if you spread them out a little bit, you can kind of get a sense of how many are red and how many are blue. Okay. And so one thing that does seem pretty obvious here is that, you know, the women and children first did sort of hold up, right? Certainly there's more blue here than there is in here. But again, the age doesn't necessarily tell you all that much. All right. So fine. So maybe, you know, a very naive classifier, just to sort of illustrate a starting point, is what's called the rote classifier. So this is, look, if I see a new record coming in, I'm going to go look for an exact match in the training set. And if I've got something that agrees on every single attribute, then I'm going to assign it to the same class. If I've seen this example before, then, you know, darn it, I know what to do. Okay. And if it doesn't, then you have to just guess. Okay, so this classifier is not particularly useful. So a minor improvement on this one is the following. You know, given a new passenger that we haven't seen before, see if it matches an existing example on some particular attribute. And if it does, then take a vote among people with the same value and see what they say, and use that to determine the class. So for example, you see a new passenger and you notice that it's female, then you can look back at all the other females you have, and if there's more females that survived than who did not survive, then you declare the new passenger must have survived as well. Okay. But, you know, there's lots of possible rules like this, one for every value of any attribute, and, you know, in a particular attribute can have more than just two values, male and female. So you need some way of choosing among these. So we have the representation of the hypotheses in terms of rules, right? Each rule is a hypothesis. Okay, so that's the representation. Now we need the evaluation. How do we determine which ones are good and which ones aren't? Well, one thing you can do is construct a confusion matrix, which is a square matrix with a number of rows and columns for each unique label, each unique class label. And the diagonal of the confusion matrix will tell you which labels you got right. Okay, so for example here, using this one simple rule that looked pretty good when we drew the scatter plot, if sex equals female, then survive equals yes, otherwise no, we have 468 instances where we classified the passenger as having not survived, and indeed they had not survived. We have 233 cases where we classified them as having survived, and they did indeed survive. And the other values are the mistakes that we made. We classified 109 as having survived who actually did not, and we classified 81 as not having survived who actually did. Okay. So this is actually useful for sort of visual inspection, but it doesn't really give you a single number that you need in order to actually, build a program that would do this automatically. So what you can also do is just measure the accuracy, which is here, 468 plus 233, the number we got right over the total number covered by the rule. And in fact, we didn't have any missing values with male and female, so they're all covered by the rule. Is about 79% correct and 21% incorrect. So this is not too bad, given that it's such a simple model. Okay. Fine. So another scatter plot we could look at, maybe in an attempt to improve upon it, is look at the, whether they were in first class, second class, or third class. And here, we don't have sex on here, which is a pretty strong indicator, but we do see some interesting patterns. It looks like people in first class tended to survive more, certainly more than people in third class. And then it looks like the kids in second class tended to survive more than the adults in second class. Okay, so this suggests a slightly more complicated rule. Okay. But here's just another example of a simple rule just for class itself. If you're in first class, then you survive. If you're in second class, then you survive. But if you're in third class, then you don't. And so now, the confusion matrix we can build again. Remember, the confusion matrix is just the class label, so it's still just no and yes and no and yes. And how do we do here? Well, the diagonal tells us 372 plus 223 over the total number is only 67% correct. So it's a little bit worse. Okay, so we have a representation of hypotheses and we have an evaluation method, but we need some kind of a search strategy to consider all these rules. And so for the one rule case, you conceivably could just enumerate all of them. And so one potential search strategy, maybe I hesitate to call it optimization, is just to do so. So the one rule algorithm is this. For each attribute A and for each value of that attribute, create the rule. Count how often each class appears, find the most frequent class, and generate a rule if A equals V, then class equals C. Okay. And then you can calculate the error rate of that rule. Pick the attribute whose set of rules produce the lowest error rate overall. All right. And now you'll have one rule. Now, by the way, one rule, again, refers to actually an attribute. So it's an if then, if then, if then, if then, covering all the values of that attribute, not just, for male and female, that's not two rules, that's just one rule. Okay, so this is kind of an exhaustive search strategy for which to generate these rules.